All right, good day, everyone. This is Jason Strait with the Cloud Pass Virtual Group. Our presentation today is Introduction to Azure Machine Learning with Ravi Kumar. Before we get going, I have a few announcements, and I'll just run through those pretty quick here. So as I've mentioned in some of our more recent webcasts, our virtual group is now being sponsored by Microsoft. They're helping us to get some additional speakers as well as make sure that we have everything that we need to run this virtual group smoothly. If you are not yet a member, I do recommend becoming a member of the Cloud Virtual Group. You can do that by going out to cloud.pass.org, signing up, and what that'll do is get you access to the newsletter that I send out about weekly that lets you know about upcoming webcasts. Currently in the pipeline, we've got a number of webcasts that are scheduled between now and the beginning of March. These cover everything from uSQL to cloud data warehousing with Azure Data Warehouse, Data Factory, Databricks, kind of everything under the sun when it comes to data in the cloud. If you are interested in presenting, I'm, of course, always looking for more presenters. We try to do 2 presentations a week. So if you are interested in presenting and you've got a topic that you'd like to talk about, whether it is a deep dive, whether it is just your experiences with it, anything that's cloud and data related, we kind of want to hear about it. So you can email us at cloud@pass.org or go out to the website for the virtual group and fill out the form that's there. If you did miss Pass Summit 2019 this year, you can get access to all of the sessions. They are available now, so you can just go out there and order them up. And then this virtual group is part of a number of virtual groups that Pass helps to put together to give people lots of opportunities to learn about building data platforms on Microsoft technologies. Throughout the session, if you have any questions, please type them into the question panel, and then at the end of the session, and I just realized that my screen wasn't moving forward, so hopefully everything that I had said makes sense, but dang pause. If you do have any questions, please type them into the question panel, and we'll go through those at the end of the session. So with that, I'm going to just skip over going back to those slides that I kind of highlighted over and just hand things over to Ravi here for his presentation today. So Ravi, I'm going to make you presenter.
Thank you.
There you go. You are now the presenter.
Okay, you show my screen.
Looks like it's about to come through. Let's see here.
Give me a second. I am fixing something on my end. Need to put my PowerPoint into presentation mode. I need to change. I have one of the monitors is really, really huge, and you don't want to see that on the screen.
Okay.
Make sure this works. Okay, yeah. And show your screen.
There, yep, I can see the display settings.
I can't. Which screen are you looking at? The Azure Machine Learning one?
It shows display settings. Like it shows Microsoft Teams and then Explorer.
Is there a way to switch that?
Yeah, on the first tab where it says sharing, you can go to webinar. There should be a down button under the show that'll let you to switch screen.
Oh, show screen. Okay. Monitor 2. Okay.
Yep, I can see the slide deck in design mode. Yep, looks good. And I'll also mute myself now.
Okay, thank you. Hello, everyone. Welcome to Azure Machine Learning 101. My name is Ravi Kumar. I am a premier field engineer with Microsoft. My job is I tell other people what to do. Some of you may be laughing, but it's true. Um, Usually, I consult with big companies and I don't actually do the work, but I am looked at as a trusted advisor. My background is mostly in business intelligence. Historically, it was SQL Server reporting services, analysis services, integration services, and reporting and data warehousing. Past few years, it has switched over to Power BI and machine learning. What we're going to be talking about today is I am not going to teach you, hey, these are the algorithm you should be using. But what we're going to focus first on is what is this machine learning and what are some of the use cases, how you can use it, how I have used it in the past. And I'll try to simplify that because machine learning term it has been thrown around quite a lot recently, and you must have heard a lot about it. So we'll talk about that, and then I will tell you and I will teach you how to get started. And once you have that starting point, you can easily go ahead and start learning learning machine learning on your own. Okay, so let's go. So I'm just going to talk about hype. What is machine learning? So good. All right. We all look at, hey, we have self-driving cars now. We have robots that are reading. We have facial recognition now. And machine learning is the best thing that has ever happened to the IT. But on the flip side, we have, hey, machine learning is invading our privacy. It's more like a Skynet and it's going to take over the world. It's going to activate all the robots and we're all going to die. Well, it's a little bit more than that. So let's dig into details a little bit. In the past, it's been conventional programming. That means we have a set of rules, and we go through a set of rules to come up with some type of decision. For example, hey, if I get email from my manager, send it to spam. Or if this happens, then go ahead and do this. If the price of this product is more than 500 degrees, is more than $500, set it as a premium product. Or one of those things. So it's set of rules and it's if this, if that. And usually humans, they do all the intelligence to say, yes, we are going to decide on the rules. For example, we want to look at what is something out of the normal. I'll give you an example of programming. I was running integration services package for a company, and our normal records were between 200, about 10 to 200 every time we ran the package. But every now and then they would mess up and send us the whole data set of about 20,000 records. It would go and it would corrupt our data, and we would spend 3 days cleaning it. So what I said, hey, if it's packages more, if we have rows that are more than 300, fail the package and send us an alert. It's conventional programming because I get to decide the intelligence behind it. It is not intelligence. We can solve lots of problems with conventional programming. For example, when should we be sending our we should be sending our marketing emails? Great. Who should we send to? We already know that. But when should we sending it? Well, that requires intelligence. That's something conventional programming cannot solve. And that is when we start talking about machine learning. We talk about new problems. And if we are trying to solve new problems, we have to think about new ways. And the new way to think about it is called its probability. It's not hard fast rule. It's what is the probability 0 to 100% that this is going to happen. or what is the probability that what is the probability that my sales are going to be 100,000 next month? Machine learning is all about probabilities. Let's talk about some examples. What's a good price for a product? Right? We can decide that. Well, we can, but it'll take about 10 people in a boardroom arguing over for 3.5 hours to figure out what's a good price. And they will use all kinds of spreadsheets and data to figure out what's going on. And it could be multi-day process. How often should we be sending marketing email? Should we be sending marketing email 10 times a day? Probably not a good idea. Everybody's going to unsubscribe. Or should we be sending it once a month? Well, we're not going to get the results we're looking for. So how do we decide that? Requires intelligence. How likely is this customer going to renew our contract? Right? There might be many, many variables that are associated with this. Twitter, just by reading a tweet, we can kind of tell, yeah, it has a negative emotion attached to it, or it has a positive. But we cannot go through 500 million tweets, just one person. Otherwise, we would need to hire an army in order to do that. Not really possible. But can we tell a machine that is positive or negative? Absolutely. Or we're hosting our website. Is our website being attacked? Well, how can we tell that? Now, all these examples, they may not apply to you, but again, I am giving you a starting point, and these kind of examples can be a really, really good starting point. Now, you might have heard a lot about these different types of words: deep learning, supervised learning, unsupervised learning, data science, data mining, artificial intelligence, multi-layer perceptions, different types of regressions. Yes, these are great, but let's step back for a second. These are different types of data science, you can call it, but let's step away from it and just talk about artificial intelligence. We have heard a lot about it, and machine learning, you can say, is a type of artificial intelligence, but it doesn't get smart, or it doesn't get any intelligence by itself. We need to teach machine learning. We need to teach this artificial intelligence, because we have the intelligence and we need to provide this intelligence. Okay? For example, chess. Let's talk about chess real quick. Let's say if I'm trying to teach you chess. All right. How would we start? Just think about it. If you are trying to teach chess to somebody, how would you start? I'm going to pause for 5 seconds, and I want you to think about it. Okay. We will probably start by explaining the rules, saying, hey, these chess pieces can move this way, and these are the rules. If you get here, this is what happens. Now, if you did not teach somebody, that person, and they watched for long enough, they'll eventually learn. But we speed up the process by teaching them the rules. Think about machine learning the same exact way. That we are giving them a set of rules that, hey, these are the set of rules that you should be looking for, or you should be looking at, and then the machine, it could be trained to do just that. Okay, we're gonna play a mind ninja game. Okay, I will show you a picture on the left, and on the right side, I will show you that how you feel. That's it. Next. 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 Let's go through this one more time. Next. Next. Now, what do you think our emotion is going to be here? And you guessed it correctly. It is happy. Well, welcome to regression. You have just learned and you have been just trained that, hey, something is happy and something is not. We have provided example. We did not need to describe it. This is a classification that we provide something, enough negative and positive information to tell you that, hey, this is happy, this is not happy. We give you enough examples of, hey, this is a spam and this is not spam. Machine learning, this is a classic example of algorithm called classification. Jason, do you have any questions so far?
Nope, no questions yet.
Okay, thank you. We'll come back to this algorithm, but let's take a look at this life cycle real quickly. We need data. In order to develop something like this, we need data, and we need lots of data. Two of the major components of creating a machine learning algorithm is getting the data and cleaning it up, and then analyzing the data. Once you have analyzed the data and you have modeled it, everything is easy from there. We'll go through different algorithms here very shortly on a high level, but let's take a look at some problems with machine learning. Machine learning is a black box. Once you have designed it, or let's say if somebody else designed it, and you start getting certain results, but you don't know why you're getting those results. And if you need to know why, we need to start looking at the algorithms. Now, also these algorithms, right here, let me turn on the zoom so we can focus on this, actually. There we go, pointer options, pen. Let's focus on this part real quick. Right here, analyzing the data. We can get the data easily, but then we have to analyze it and give a result back. Hey, this is happy, this is not happy. What are we looking at? Is it a dog? Is it a horse? Or is it a ostrich? Could be any of the animals. But there's a programming in the back, and these are called algorithms. And those are the ones that determine your decision. Now, we might have done some programming but do we need to learn how to write algorithms? Probably we don't, because that is where the cloud providers and cloud solutions come in, and that is where your barrier to entry in the past was so high because you needed to write the algorithms. In this case, it's just a drag and drop. Cloud providers do provide that. We're going to be talking about Azure machine learning today, And with Azure, it's just a drag and drop. You still need to understand that what these algorithms do, and that is when we talk about it as a black box. That yes, we can start using this algorithm. You might say, hey, this algorithm get me better result than the other one. I don't care how it's what's in the black box. I get better results, so I'll just use this one. And in the future it changes. Well, I'll just retrain a model and use some other algorithm. And many people do that, and that's completely fine. But if you need to know why, we need to start looking at different algorithms. We have classification where we just talked about, hey, is a cat, it is not, is it a dog or is it not a dog? Or multi-class could be, hey, is it a dog, cat, or is it a boat? Could be any of them. Regression is another type of algorithm. Regression is not, we're not looking for some type of result, but we're looking for some type of number where, and it might have a large amount of variables. For example, we're looking at, hey, we're trying to decide a price about of our new product. Well, there might be variables. What many variables? What color is it? What's the size of it? What market are we selling it? What is the demographics of the market? What is the build quality? Some of the reviews, and it could be many variables that we might need to take in effect, and then figure out that what is the amount we should be setting for this. And it's really good if we have large amount of variables. Let's say you're trying to sell your house. Well, there could be many variables in order to decide the price. That is what websites like Zillow do. They look at what the other houses are selling for, the school district, your square footage, when it was renovated, and it could be many different things. And it is all part of regression. And this is what we call supervised learning, which is where we are telling the model, hey, this is good, this is bad. So, which means we need to have data, we need to have sample data, and we need to have good data, and we need to have lots of data, so we can provide this data to the model, and we can train it. Supervised learning. There's also unsupervised learning. Things like cluster algorithms, clustering and anomaly detections. Let's talk about that real quick. So we talked about supervised learning, regressions, we talked about classification, two-class and multi-class. We also have unsupervised learning, where we're trying to ask the user that give me the clusters or help me understand this data. Power BI actually recently came up with, if you create a scatter plot, you can divide it into clusters. Clusters are groups. You're trying to determine the structure of the data. Hey, do I fall in this group 1 or group 2? And anomaly detection is you tell the model that, hey, this is what's normal. Give me something that's out of the normal. And it's more of a, wait, what? That's weird. It shouldn't look like that. For example, on your network traffic, if something is out of the ordinary, we might be getting attacked. Lots of cybersecurity companies use this. Credit card companies use anomaly detection to figure out, well, this might be a good charge or not. Well, you've been charging a card in Washington, D.C., and 1 hour later, you're getting a charge, you're swiping your card in California. Well, that's out of the norm, right? So it's probably, and we should probably go ahead and deny that. Okay. So we talked about this. In order for these to work, we need to provide this data. Supervised learning, we tell it, hey, what's normal, and give me this. Unsupervised learning, saying, hey, I don't really know the results and what data I'm going to get, but this is what's normal. Give me what's not normal. And these are the 4 type of algorithm you're going to see in machine learning. Any questions on this so far?
Nope, no questions.
Okay, great. Now, we talked briefly about this, training the model. We usually take 80% of the data again, this is when we are creating and we are developing a model. We take usually 80% of the data and we model it and we train that. And we use 20% of the data to validate. What do I mean by that? Let's say you have 1,000 rows of data. You're trying to figure out movie profits. And in movie profits, you know the rating of your movie, what genre it was, which uh, um, uh, uh, who released the movie, and when it was released, what month. So 4 variables, and if it made profit or not. You already have this data solid. So what model does, out of the 1,000 rows, it'll take 800 rows to train the model to figure out, hey, what is the end results going to be? Then it takes the 200 rows and figures out hey, what is the results of these 20% going to be? Tries to predict that and compares it on those 200 rows. So this is, especially when I was getting started with machine learning, this was really tough to wrap my head around. Let me reiterate this one more time. We have 1,000 rows. First, model is going to say, hey, give me these 8,000 rows, 800 rows, and show me what's normal. Then it'll take those 200 rows without the result, without if a movie made profit or not profit. It'll take the rest of the 4 variables we talk about and tries to predict the if for those 200 rows, it'll try to predict if movie made profit or did not make profit, and then it'll compare the 200 rows. It came up with a result, then it'll compare that with real data that you already have, and that would give your model valid that how good your model is. And you might need to run that through different algorithm to figure out which one works the best. And that is why most of the algorithm that I will show you on machine learning, they are available there. For example, let me show you real quick. Let me pull up Azure Machine Learning Studio. Where is it? There we go. This is an experimentation, and notice under machine learning here, we have classification, anomaly detection, clustering, and regression. But under each of these, we have many classification available. We have one clustering and few regressions available. And you might need to run through many of these. And so this is where most of the work comes in. You might need to go through the 2-class. Hey, average perceptron, base point, boosted decision tree, and you might run through 4, 5, 6 of these and train your model and figure out which one works the best in your case. In the model I'm going to show you, you will be using 2-class logistic regression. Questions about that?
Yeah, the only question we got the moment is, what is the validation process in this context?
What is the validation process in this concept? Validation process is the 20% of the data, or in our example, we had 1,000 rows, so 200 rows that you already know that this is the real data. This is what happened in the past. We are looking at the historical data. So we go back and say, for these 200 rows, we're not looking at, first we're gonna hide our result because we already have it. We're gonna try to predict the result and then compare it against the 200 rows, and that'll give us an idea of how good our model is, and the model gives auto scoring that how good the model is. Does that answer the question?
He says no. He's asking, what is the base to say 80% model and 20% for validation?
What is the basis? Yes, that is what we have seen most of the people use. Some people do 70 and 30, some people do 75, 25. But that is the normally industry standard we have seen.
Okay.
Okay. Thank you. Right. So your main work around here has to do with data cleanup and building the model. Once you're done with building the model, it's just a click of a button that you score the model and then you consume the model. From there, everything is downhill, but most of your work is data cleanup and building the model to make sure, we need to make sure there are no missing values and other things. Okay. And that is why we set up an experiment. Let me go here. Usually what we have to do, at least in machine learning, you register the data. That means register here means you get the data from the source. This is all in development. We're not in production yet. You start with saying, hey, get the data from somewhere. It could be on your computer. It could be in a storage account. It could be in the database. There are many sources available. You get the data, and then we apply a machine learning algorithm to train the data. Then we evaluate the model. The evaluation of the model is the one that we say, hey, take 80% of the data and evaluate how good it is against the 20% of the data. Once we are, and this might be iterative process. You might come to say, hey, my model doesn't evaluate that well, so let's go back and we're going to go ahead. We might choose a different learning algorithm and evaluate the model again. Well, that didn't work. Let's try it again until you're satisfied. Once you are, then you can deploy the model directly via web service. And there are other deployment options available recently. Okay, any question?
Yeah, the one question at the moment is, how is data scientists involved in picking which model to test with?
How are data scientists involved with picking the model? Well, it'll be a question. It depends. If you are a data scientist and you've already written some type of algorithm in R or Python, we can import that directly in Azure ML. If you are working with the developer, then I would say work with developers directly to suggest, hey, this is the type of data we're getting, and these are the type of algorithm that would be the best. Does that answer the question?
Sounds like it. Um, and then also, what are the parameters for the algorithm to the side? How do you select which parameters to use?
Um, every um, every algorithm has different parameters, which I'll show you shortly. But uh, about the earlier question is how data scientist is involved. I would suggest you to look at team data science process, TDM, uh, team data science process. Microsoft has it well documented where we talk about that data science is not a one person's job. Data science is a team effort. And you can figure out the role of a data scientist within the team data science process. It requires many people. It might require a project manager, a developer, people from infrastructures, and you name it. There are many roles to play. If you have a data science project, it is not a one-person job. We have seen over and over again, if they said, hey, you're one person and you're handling everything with data science, things fail very easily because data science is dependent on many other things within an organization. Questions about this?
Not about that specifically.
Okay. Thank you, Jason. So let me show you how to go here. Um, um, Azure Machine Learning Studio. And you can sign this up for free. All you need to have is some type of micro account and Microsoft account, you'll be fine. And Azure Machine Learning Studio, where is this? So right here, studio.azureml.net. Azure Machine Learning Studio. There we go. And I have, so your lowest unit is your experiment, and you're going to create an experiment, and there are things I have created in the past that are in my experiment. But if you're starting to learn, what I would suggest you click on this new button right here. It is fantastic. It gives, you don't need data because these already have data sets built into them. Okay. What I ran earlier was this one. If you do taxi, this is New York taxi data. And this tells you that, again, I'm teaching you how to learn. This is learning with counts, which is the binary classification. Remember, what was the, now try to recall what the binary classification is. Binary classification is, hey, this is true, it's not true. This is a dog or it's not a dog. It's a horse or not a horse. Versus multi-class, you're saying, hey, is this a dog? Is this a cat? Is this a turtle? Or is this an ostrich? So let's say if we want to look at this, you can say view in gallery. It'll take you to a documentation page that has everything about that experiment. But you can say open in Studio, and it would import that and show you how the experiment is set up. Okay, that's upgraded. And you can start learning from here. You can see what's going on. We are importing data 2 times, and we are saying, hey, we're applying some type of transformation here. So we're building account transformation. If I click on this, notice it gets the data from HTTP endpoint, and data format is CSV. This is already programmed for you, but if you were building one from scratch, you would need to provide all the details to import the data. same one, and then we go to building the count. Now, if I right click on this, I can't really see the results set. The reason behind that, this is just a structure. We don't have the data in memory yet. Right? I ran this earlier. If I run this right now, it's going to take about 20 minutes to run. But if we go back to experiments, I ran this earlier. So if we look at the other one, all right, so I already ran this earlier one time, and okay. So what I would need to do, I would need to run this. Give me a second, right here. So I ran these, I got a bunch of check marks. It took about 20 minutes or so to run. But once I run this, notice I can visualize my data set. So if I look at the data set, I get another window to give me, hey, how many columns I had, how many rows. In this case, we have a little over 5 million rows we're looking at. That's why it took me 20 minutes to run, and 23 columns. And I can look at the distribution of this, or I can put it as another chart. And if I select one of these, notice I get more information about that column. I remember before all of this, I used to run SSIS packages to get these type of information. Longitude and longitude, and how many missing values and other things. And running something like this will give you a good idea of, give you a really, really good idea that how clean your data is. If you have missing values, well, if you're missing values, that might affect that how your model makes the decision. So you want to make sure you clean those up. Once we get this data, then there's a counting transform which goes ahead and counts the number of classes, hash functions. You can learn about all these, but I'm telling you about this, just a basic structure. We modify the count table, and then we apply certain transformations. If I click here and say, visualize the data set, and I get more columns. Notice in this experiment, the goal is we're trying to decide, based on all these other parameters, if a person is going to tip or they're not going to tip. And this tip column, we already have this saying, hey, this is 1 and 0, and here we have 2 unique values and 0 missing values. Okay, that makes sense. And then there's some other things that have been assigned here. Once we do that, we select how many columns are going to be in our data set. We can visualize this again. Notice we're not bringing everything. We're bringing only the variables we need to make the decision. And right here, we're looking at a random number that we have assigned, total amount, total tipped amount, and bin value. We do that, and then we train the model using 2-class logistic regression. And once we click here, notice we get, hey, this is a single parameter. What is the tolerance? L1 and L2 regularization weights, and what is the memory size going to be? Then we train the model, and we score the model, and we evaluate how good the model is. If you want to look at more details about it, you can say, hey, view the output log. It'll give you everything this has done. And we visualize the model right here. Now, this is something called ROC curve. This means that some of the predictions are not good. So the closer it is to the median, to this line, better it is. It's telling me our precision, accuracy, how many false negative we have, how many positives we had, and all the information about it. Precision and lift right here. And it gives us more information that how well our model did. At this point, we can decide, hey, this is well, or we can come here and say, hey, this regression, we have two-class logistic regression. Maybe we might try a booster treats to see if we get a better result. And this could be iterative process again and again and again. Let me show you another one. Let's go back to our experiment. And this is one of the data set that I have that was a Titanic data set. That means, and it is a little bit depressing data set. It means that, hey, based on your age and gender, if you were in Titanic, how likely were you to die? Based on how old you were. And if we visualize the data, it tells us if you survived, if you didn't surprise, name, sex, age, and some other information. We selected the columns. We selected the columns in data set. We applied some transformation. Then scored the model. We added some more column. Let's run this experimentation. Notice we get another, which is predictive experiment. That means you have gone through the training, and this is a good model. Once we're done with that, once we are satisfied with it, notice it says two-class jungle tree. We come here, select column and data set, we clean data, we edit the data, and then we train and score here. This is the part I was talking about, that, hey, 80%, which is the split data, saying 80% of the rows are going here to train the model, and 20% are coming to score the model. And this is the magic sauce. When we say score, we tell it, hey, this is coming from train, this is coming from split, and figure out how good our model is, and then evaluate your model. All right, we can look at this, visualize, and okay, the precision is not that great. This is the rock curve. And let me correct myself. The farther away we are from here, the better it is. So our previous model was really good. This is not so good. But that's all right. Once we're done with that, when we have to say run, once we run it, we say create predictive experiment. That means we are ready now and we're ready to deploy. Once we say predictive experiment, it creates few more endpoints. So your web service or other things, they can come here and they can run this model. This is your production version. And anytime you update your training experiment, say, let's say I come here and I say, hey, two-class decision jungle doesn't really give me much, so I'll just try two-class logistic regression. I update this. Once I do that, I say update predictive experiment. It's going to go ahead and update my experiment, and I'm good to go with the latest version of my trained experiment. We are good here. Once we are done, how do we? So we've done most of the work. We have brought our data in. We have cleaned our data. We have gone through iterative process of scoring our model based on different different regression or different algorithms. Once we're done with all of that, then it's time to deploy and it's time to consume. How do we consume it? One of the most common ways we consume it is through a web service. It is an endpoint you can call from other place, from any of the applications really. Must be run, so we haven't run the, so we have to run this experiment one time. There we go. It's running right now. And it might take a little bit of time. But once it is done running, then we can come here and say, hey, deploy the web service, and it'll create an endpoint for us. And once we're, and we can take that endpoint and pass in the parameters that are required for this experiment, and we can start getting results. Questions while this is running?
Yeah, one question that's out there is, are there, and actually this is me shaping a comment into a question, is there any online labs that people can use to experiment on with an end-to-end solution?
Now, question back to you is that, are you looking for a step-by-step lab where you're saying, hey, do this, do this, do this, and do this? Or yes?
Yeah, I think so. I think that's what the person would be interested in.
I don't know. I'll have to look if Microsoft has it. Microsoft have tons of learning. Microsoft have tons of learning modules. Like one of the ones I showed you was just a new experiment, and all of these, they have documentation. So one of the documentation is, and it walks you through what everything is. But I don't know of a step-by-step lab.
Okay.
As of right now. I'll research that later. Let me write that down. Jason, is it possible we can send out a message to attendees at a later time?
Oh, absolutely.
Okay. So I'll find that out and get back to you. Let me go ahead and write that down.
Sure.
I know through Microsoft Services, we offer like a 3-day workshop with labs, but I don't know if there are community things available as of now. So I'll definitely do some research and look at it. Great question. All right, we have done this. Now we say deploy web service have been selected. Will you have selected yes to publish? We are going to publish this. Yes, I am sure. And there we go. We get API key, certain endpoints. Also, one of the newer features that came out was you can do this through Excel. Here, let me go ahead and download this real quick. There we go. Open it. Let's hope Microsoft Security allows this. All right. Deck Studio. Okay. All right. It's installing something on my computer. Give me a second. There we go. This is what we get. We say enable editing. And now this is connected directly to my experiment. And if I have values here in Excel, I can type those values and they can go, there we go. Click this. view schema, what are the inputs, what are the outputs, what are the, there we go. And your Excel users can start predicting these. You'll have to enter the parameters I haven't entered. And then you can start predicting here. I can also go and say, hey, new web service experience. So this actually loads an API on this side where I can enter data, click, and it'll go against this tutorial test endpoint. Right. I think I built it in a previous version. That's why it's not working. Give me a second. Configure use endpoint, launch in Excel. Okay. But once you build this, you can use either this to test it, you can use Excel, or you can just use the API key directly and make calls through the machine learning API. And I believe we're 2 minutes out. Any last questions?
Yeah. How can we say that our model is depicting the real scenario versus whether it's how can we validate the model? That's probably the best way to put that question.
Validating perhaps I did not stress this enough, but let me go here. Validating the model, you actually do this when you are scoring the model, you're actually validating your model right here. Scoring
Okay.
and evaluating the model. These two steps are your validation, and it tells you how good your model is. Again, this is not a hard and fast rule. You are predicting things. So they might be and they might not be true. The only thing you can say for sure that, hey, how good my product is, what is the it's 99% probable or 90% probable that this is going to happen, right? We don't have, we haven't invented time travel yet. Once we do, then this will be a lot easier. But yeah, so again, this is where 80, I'm highlighting it's 80, that you're using 80% of your data, and then you're using 20% of it to validate. And again, a month later, you have more data, feed it more data. The more data you feed to this model, the better it would be at guessing. That means if you're providing it 1,000 rows, well, 1,000 rows might not predict as well versus if you provided 1,000,000 rows.
Right.
Okay. And that is
Great.
all I had, everyone. I think
Okay.
our time is
We're right
up.
on. Yeah. We're right on time, and it looks like everyone who's still here, we've answered all of their questions. So with that, thank you for presenting here today, Ravi. This has been great, and thank you everyone who's attended. Um, and with this, I'm going to close things out, and everyone just have a great rest of the year. And thank you again.
All right, everyone. Bye-bye.